All right, all right, all right. So here we're asked to find the terminal velocity of a basketball. And the stipulation is that your final symbolic equation for terminal velocity should only include constants and properties of the basketball, its mass, its shape, etc. Enter your equation here and show how you derived it in your written work. Now, entering the equation, I'll admit, was probably kind of a pain, but I hope you did your best. And I'll see the sort of normal version of it written out in your written work. But the key here is to remember that the basketball is going to have two forces acting on it as it drops. There's going to be an upward force due to drag and a downward force of gravity. And the condition for terminal velocity or terminal speed is when the drag force is equal in magnitude to the force of gravity. That means that the net force on this object, whatever it is, basketball in this case, the net force is at 0, and then the acceleration is 0, and so it can't change its velocity anymore. So that's the condition we start with. And for something the size of a basketball moving through the air, well, then we're going to use this form of drag. And of course, the force of gravity is just equal to mg. And that's all we need. We just need to solve for this velocity now. And to do that, we can divide both sides by 1/2. That gets us something that looks like this. And then we divide everything by all of the other constants here. And that gets us v squared is equal to 2mg times the drag coefficient times the density of the air times the cross-sectional area of the basketball. And then we just take the square root of both sides to arrive at the terminal velocity being the square root of 2mg c rho times a. All right, so that is all you need to do. Nice and simple, hopefully. Okay. Mostly it's remembering that this is the condition for terminal velocity, and that this is the appropriate type of drag force to apply, the v squared pressure term rather than the linear NV term.